Okay, in this video I want to talk about the commutative property of addition and multiplication and the associative property of addition and multiplication. The commutative property of addition says that a plus b is exactly the same as b plus a. Let me show you what I mean by that. If I have 3 dimes over here and 7 dimes over here, that gives me 10 dimes altogether. So what we have right here is 3 plus 7. But now if I were to take 7 plus 3, I just switch them around. So now I have 7 dimes over here on the left and 3 on the right. It's still going to give me the exact same result. I still have 10 dimes altogether. I can have 3 dimes up here and 7 dimes down here, or I can have 7 dimes up here and 3 dimes down here. No matter how I group them, 7 plus 3 is going to be the same as 3 plus 7. So this principle is helpful because if you ever see 3 plus x equals 5, for example, you can go ahead and rearrange that if you want to say x plus 3 is equal to 5. Because just like 3 plus 7 is equal to 7 plus 3, 3 plus x is equal to x plus 3, it works no matter what the numbers are. So that's the commutative property of addition. Now let me show you the associative property of addition. The associative property of addition tells me that if I have 7 dimes here, 3 dimes here, and 4 dimes here, so 7 plus 3 plus 4, that's exactly the same as 3 plus 7 plus 4, or 3 plus 4 plus 7, or 7 plus 4 plus 3. No matter how you can rearrange them, it's still going to have exactly the same number of dimes on the floor. That's just the way that addition works. You're grouping a certain number of things, and no matter how you rearrange them, you're always going to have the same number of things altogether. So again, if we're talking about a situation in algebra, we might have 3 plus 5 plus 4 plus 6 plus x plus 7 equals 63. Alright, if we have a situation like this, we're not going to be able to solve for x if it's right there in the middle of things, but we can really easily rearrange it and put the x at the end or at the beginning. We can do whatever we want with that. So that's an important thing to remember with the associative property. Another example of why the associative property is helpful is because, say we have a situation like 42 plus 6 plus 83 plus 17 plus 4, and we want to add all these up. Well, you could take 42, add 6, you get 48. 48 plus 83 is, I think, 131. Plus 17 is 148. Plus 4 is 152, I think. But a much easier way to do that, since we can add in any order we want, according to the associative property, it doesn't matter. We can rearrange these however we want. Let's say take 83 plus 17. Well, that's 100. Add 42, that's 142. And then 6 and 4 is 10. So add 10 to 142, and you've got 152. See how much easier that was? And the only thing we did was we added them in a different order. So the associative property just tells you that you can add things up in whatever order you want and still get the same example. And that 4 is bugging me. That should look like that. Okay. So the commutative property of multiplication is very similar to the commutative property of addition. It says that a times b is equal to b times a. It's going to give you the same result. So one way to think about multiplication is to think of it as adding the same thing to itself a certain number of times. So I'm going to take 3, and then I'm going to add 3 to that. So I've added 2 3s to each other, so now we have 3 times 2. That's 3 times 3. 3 times 4, and 3 times 5. So I've just added 3 to itself 5 times, or I've multiplied 3 by 5. Alright, so I've got this one group of 3's right here, another group of 3's, another group of 3's. You can see how each group of 3's is added to the next one. Alright, so that would be 3 times 5. But wait, watch this. What if you think of this group as a group of 5, and this as a group of 5, and this is a group of 5, so really we can say that we added 5 to itself, and we have 3 groups of 5 right here. So we could say not just 3 times 5, but 5 times 3. It's the same thing. So that's the commutative property of multiplication. Another way to think about it is if we have, say, I'll just do the smaller numbers here. If we have 2 times 3 here, it's exactly the same as 3 times 2. So let me give you some examples of how the commutative property of multiplication might work. We could have 7 times 3, right? And that's going to be 21. But 3 times 7 is also 21. I could have 8 times 9 is 72. But 9 times 8 is also 72. Or I could have maybe, let's see, 4 times negative 2 is going to be negative 8. But negative 2 times 4 is also going to be negative 8. Alright, so the associative property of multiplication is a little bit trickier to do with dimes, because if I'm multiplying 3 numbers by each other, I'd have to use 3 dimensions, and I don't want to float dimes in midair. But you might be able to guess it already. It says the same thing as the associative property of addition, that if you have a group of numbers all multiplied by each other, you can multiply them in any order you want. So if I have 8 times 3 times 5 times negative 6 times 2 times negative 4, whatever group of numbers I have, if I want to multiply these numbers, I can multiply them in any order I want. So I can go 8 times 3 is 24, times 5 is 120, times negative 6 is, negative 720. Or I can go 8 times 2 is 16, times negative 4 is, whatever. I can multiply them in any order I want. In this case, it would probably be better for me to start with the negative numbers. Since the negatives will cancel, I can do negative 6 times negative 4 is positive 24 and go from there. Or I could start with the 2 times 5. That's going to give me 10, so I can just take that and multiply my final result by 10, right? So there are a lot of ways that the associative property of multiplication can help you there. And I can also prove the associative property of multiplication from the commutative property of multiplication. See, if I want to prove that you can multiply these in any order you want, all I have to do is switch 2 of them at a time, right? I have 8 times 3 here. The commutative property tells me that I can rewrite that as 3 times 8. But then I have 3 times 8 times 5. And the commutative property tells me that 8 times 5 is the same as 5 times 8. So I really have 3 times 5 times 8. And then if I want to take this negative 6 here and move it all the way to, say, right between the 3 and the 5, I can use the commutative property to switch it with the 8, and then use the commutative property again to switch it with the 5, and that will give me 3 times negative 6 times 5 times 8, and then, of course, I have the 2 and the negative 4 still here. So the associative property follows directly from the commutative property, same as it does for addition, actually. So those are the commutative and associative properties. Again, you probably would have known already that you could do all of the things that I said you could do. But even if these were things that you already know, it's helpful to know what you know,